Okay, so in this video we're going to start looking at the exponential distribution. The actual scenario that you're dealing with is very similar to a Poisson, where you have successful events occurring over a time frame or under a measurement interval of sorts. There's a lot of similarities in terms of how you identify a Poisson and how you identify an exponential, because they are the same situation. It's just how you go about tackling that question. Whereas Poisson is dealing with the amount of successes in a given interval. Exponential is flipping that question and dealing with the amount of time between the successes. So instead of how many cars in a minute, it'd be a case of how long between cars. So for example, if I'm expecting 4 emails in an hour, I would be expecting 1 email every quarter hour. So if you know you're dealing with the time interval or the measurement between successes, then you'll write EXP, exponential, instead of PO, Poisson. You have the mean, which doesn't come as a surprise. If I'm expecting 4 emails, like I said, in every 1 hour, I'd be expecting 1 email in 1/4, a quarter hour. The variance formula is also in the form booklet with the mean formula. The standard deviation happens to be 1/λ, which is the same as the mean. However, that one's not in the form booklet. So there's a slight difference there. In a Poisson, the mean and variance were the same, whereas in an exponential, the mean and standard deviation are the same. But that's not the most important feature. The key formulas are in the form booklet. That's the main thing. If you need the standard deviation, of course, square root. You've got the same conditions, so Rickle. I want to focus on working out probabilities. So this probability, this formula here, this 1 minus e to the minus lambda x formula, that is for the cumulation up to and including x, so less than or equal to x. It always starts at 0. It's a bit different to normal in the sense that normal could be minus infinity as a start, whereas you wouldn't be expecting negative time until the next success. So in theory, you're always starting at 0, hence that x greater than 0. But that's not the important bit. The key thing is less than or equal to is the formula that you're given. If you need to do a greater than or equal to, you simply use that formula and then subtract from 1. If you have an in-between, then you need to do the upper minus the lower. Okay? Because it's a continuous data set, it's actually impossible. All right, so continuous distributions, it's impossible to have an exact. So when it comes to working out less than, it's actually the same as less than or equal to. So don't focus on the equals. It's just like a normal, whatever value you see, whether it's less than or more than, you do actually use that. And that's the main difference when it comes to calculating probabilities, because in Poisson, with it being discrete, you would have to think about it. Do I include the 6? Do I include the 9? So here we've got an example about an engineering firm, and they want to monitor warning signs, etc., to do adjustment and a process. So X hours, luckily, units are the same. That's the very first thing you should be looking for in any exponential. Here we're dealing with X hours and 10 hours, 20 hours, 2 hours, 50 hours. So X is 10, X is 20, etc. There's plenty of questions out there where it's in thousands, so be very, very careful. It talks about a parameter of 0.08. I've already previously highlighted this in my first draft of this video. But yeah, if you've got a parameter 0.08, that is not the exponential mean, it's actually the Poisson mean. But the key thing is 0.08 is the parameter, it is the lambda that we use to describe this distribution. So x squiggle exponential 0.08. Looks like a pair of sad eyes. Okay. Now if I want between 10 and 20, I'm going to have to do an in-between. So judging by that previous formula, I'd have to do less than or equal to 20 and then subtract less than or equal to 10. It's simply in between those two. So less than or equal to 20, subtract less than or equal to 10. So I'm going to use that formula, that 1 minus e to the minus lambda. Lambda was 0.08. For the first one, it's 20. And for the second one, it's 10. So let's see what that looks like on the calculator. So those brackets are going to be important because they're going to separate the less than or equal to's. So less than or equal to 20, so 1 minus e. Now, e is shift ln, so shift ln. Don't forget that negative. You can use the minus or the negative. 0.08 times 20. Now, if I put the bracket there, it's going to say syntax error, so be warned, scroll across, then bracket. You could work out these probabilities separately, and that's completely fine, and then do the subtraction later. And again, I'm going to have to scroll across to complete that. So you're using this E button, this 2.718, this very special number, which if you get a chance, get me talking about that. That is found under Shift ln. And that gives us a probability of 247. Now I think the in-betweens are actually tougher to calculate than the simple less than or equal to's, or even the more than or equal to's. So if we look at part 2, hopefully with some neater handwriting this time, Philip. It states less than 2. So 1 minus e to the minus lambda, x, which is just simply 2. So let's type that again. So 1 minus, so shift ln, so shift ln creates that e to the minus 0.08 times 2. One, 4, 8 to 3 significant figures. Okay, whereas longer than is the wrong way. We've got to do less than or equal to. So part 2 was a less than or equal to. However, part 3 is actually a greater than. So we've got to do 1 minus less than. And the issue here with exponential is the probability of less than or equal to formula already has 1 minus in that formula. So with a little bit of space down here. So we're going to have 1 minus 1 minus. And that bracket is going to be very important. So let's see how that looks on the calculator. So 1 minus, open up a bracket, 1 minus. Now some of you who can deal with this algebraically will know what happens with the 1 minus and the 1 minus. And of course the double negative. And that's fine if you suss that. However, I would ask you to show the examiner exactly how you'd be expected to type it in. Now I'm not going to put the bracket just yet. Scroll across, bracket. That's a very small number, which is what you'd expect. It's very unlikely it's going to take longer than 50 hours to finally be called into action to do some sort of purpose. So 3 significant figures, not decimal places, that would be 0.0183. Ooh. And just to complete it all off, if we have a look at part B, it asks for the mean and standard deviations. Now I'm going to do this properly. Now I know the trick about standard deviation, however, in the formula booklet, you have the mean of the exponential, which is 1 over lambda. You can use your fraction button, which is this one here. Oh, 12.5, that's nice. Okay, so 1 over lambda for the mean. Now if I do the variance this time, the formula is 1 over lambda squared. I'm going to retype this in, so 1 over lambda squared. 156.25. Now if that's the variance, the standard deviation must be the square root of that. And if you square root, shift, square, your answer, answer button is shift, negative. So shift, negative, so square root answer. 12.5 as well, what a surprise. So read the question carefully, it will ask for the variance, therefore 1 over lambda squared. If it happens to ask for standard deviation, all you've got to remember is to square root your variance once you've calculated it. Hope this goes through the basics of using the formulas for probability. Less than or equal to is what the probability function does. Greater than or equal to, you do 1 minus the formula. If it's in between, you do the formula twice and do a subtraction. 1 over lambda is in the form booklet for mean, 1 over lambda squared is in the form booklet for variance, and if you're asked for standard deviation, only then do you square root. I hope you find this useful. Again, apologies for my penmanship. Yeah, good luck with your assignment.